Hey everyone, and welcome. Today we're jumping into a tool that is an absolute game changer for anyone working with Linux, Logical Volume Management, or LVM. This is going to completely change the way you think about disk space, moving you away from those rigid, old-school partitions into something way more dynamic and flexible.
You know the feeling, right? You set up a new server, you try to perfectly plan out your partitions, and then a few months down the line your /home directory is totally maxed out, but you've got tons of free space sitting uselessly in /var. You're just stuck. You can't just stretch one and shrink the other. Or can you? Well, that exact headache is what LVM was built to solve.
So what LVM really does is it puts this flexible layer. Think of it like a middleman between your actual hard drives and your operating system. Instead of your OS being locked into talking directly to a physical partition, it talks to LVM. And that simple change gives us incredible power to do things like combine disks and resize volumes while they're running, stuff that's just impossible with traditional partitions.
Okay, so here's our game plan. First, we'll cover the basic ideas behind LVM. Then we'll dive into its core building blocks. After that, we'll walk step by step through creating your first LVM, see the magic of resizing it, learn how to clean up your setup, and finally, I'll give you a handy cheat sheet with all the key commands.
To really get a handle on LVM, you first have to understand its three core components. Seriously, once you grasp how these three pieces fit together, everything else is going to click right into place.
All right, let's break this down. At the very bottom, you have your physical volumes, or PVs. These are your actual physical hard disk partitions, like /dev/sda1. Simple enough. Next, you take one or more of those PVs and bundle them together into a big pool of storage. That pool is called a volume group, or VG. And then finally, from that giant pool, you get to carve out usable chunks, which are basically virtual partitions. We call those logical volumes, or LVs. And that is what your operating system actually works with.
Honestly, this is the best way to think about it. It's just like Lego. Your physical volumes are the individual bricks. You take all those bricks and you toss them into one giant bin. That bin is your volume group. Then, whenever you want to build something cool, you just reach into that bin and create a new structure. That structure is your logical volume. And the best part, if you need to make it bigger later, you just grab more bricks from the bin and add them on. Okay, enough theory. Let's get our hands dirty and actually build an LVM setup from scratch. We're going to go through this step by step, just like you would on a real Linux system. First things first, we need to tell LVM which of our physical disks it's allowed to play with. Now, a key prerequisite here is using a tool like fdisk to mark your partitions as type 8E for Linux LVM. Once you've done that, you run the pvcreate command. This command basically slaps a label on the partition that says, "Hey, LVM, I'm ready to be part of your storage pool."
And listen up, because this is super important. When you run pvcreate, it writes some data to the beginning of the partition, and that will absolutely destroy any file system that's already there. So I'm going to say it again, never ever run this on a partition that has data you care about. Always start with a clean, empty partition.
Okay, so we've got our Lego bricks prepped and ready to go. Now we need that big box to dump them in. For that, we use the vgcreate command. We give our volume group a name, here we're calling it LinuxVG, and then we tell it which physical volume to add. And just like that, we've created a unified pool of storage. With our storage pool ready to go, we can finally create something we can actually use. We use the lvcreate command. Let's break it down. L3G just means I want this to be 3 gigabytes, and nlinuxlv is just us giving it a name. This command carves out that 3 gig chunk from our volume group, and that becomes our new flexible partition. So we've made this awesome logical volume, but right now the operating system can't actually do anything with it. We have to make it usable, and that's a 3-step process you're probably already familiar with. First, you format it with a file system, like ext4. Then you create a folder to be the mount point, and finally, you mount it. Now our /tester directory works just like any other folder, but underneath it's powered by our super flexible LVM setup.
And now for the main event. This is the feature that makes LVM an absolute game changer. Let's imagine our 3 gigabyte volume is starting to get full. With LVM, we can make it bigger, live, without unmounting it and without any downtime. This is where the real magic happens. The first step is the lvextend command. Look how simple this is. -L plus 2G literally just means add another 2 gigabytes to this logical volume. LVM then looks at the free space in our main volume group, grabs 2 gigs, and tacks it onto our LV. It's that easy. So at this point, if you check, you'll see your logical volume is indeed bigger. The job's done, right? We can pack it up and go home. This is a very, very common trap that a lot of people fall into.
Whoa, not so fast. We're not done yet. See, this is where you have to remember the two different layers we're working with. We told the LVM layer that the volume is bigger, but the ext4 file system that's living inside that volume, it still thinks it's only 3 gigabytes. It has absolutely no idea about that extra 2 gigs of empty space we just added.
And this is the final, critical piece of the puzzle. You have to run a command like resize2fs. This command talks directly to the file system and says, hey, wake up, you've got all this new room to play with. Go ahead and expand to fill it all up. Once you run this, that new 2 gigabytes finally becomes usable. This two-step process, extend the volume, then resize the file system, is the secret sauce.
All right, building stuff is fun, but being a good sysadmin means you also know how to clean up after yourself. Tearing down an LVM setup is just as easy as building it, as long as you remember to do things in the right order.
The logic here is really simple. You have to tear it down in the exact reverse order that you built it. First, you unmount the file system, so it's not being used. Then you remove the logical volume. After that, you remove the volume group it was in. And finally, you remove the physical volume markers, which returns those partitions back to their original clean state.
You know, we've thrown a lot of commands at you, so let's just pull everything together in one simple cheat sheet that you can come back to whenever you need it.
This really boils it all down, doesn't it? You can see the whole life cycle here. Create, extend, and remove. And what's really cool is, look at the pattern. PV create, VG create, LV create. Then on the other end, LV remove, VG remove, PV remove. It's also consistent and logical, which makes it way easier to remember when you're on the command line.
And finally, let's just hammer home the golden rules. If you walk away with anything from this, let it be these 4 points. Number 2 is the one we keep talking about. Always resize the file system after you extend a volume. And number 4 is just good advice for life. Even with an awesome tool like LVM, always have a backup before you start messing with your storage. So there you have it. You now have the fundamental knowledge to manage Linux storage like a pro. You can grow your file systems on the fly, combine a bunch of small disks into one massive pool. You have a new superpower. So the real question is, what are you going to build with it? Maybe it's a home media server that's always growing, or a critical database that you just can't afford to take offline. The possibilities are wide open.